And in the second half it is given that in triangle PQR, if angle P is equal to 100 degrees and PM bisects angle P and PM is also perpendicular to QR, then find angle Q. So let us draw a rough figure according to the given information that there is a triangle PQR in which angle P is equal to 100 degrees and PM bisects angle P and also PM is perpendicular to QR. We know that a bisector of an angle PM will be perpendicular to QR if and only if the given triangle is isosceles. Therefore, we get angle Q is equal to angle R. Let it be as sum x. We know that by angle sum property, sum of angles in a triangle is equal to 180 degrees. We can say angle P plus angle Q plus angle R is equal to 180 degrees. That implies angle P is nothing but 100 plus angle Q is nothing but x plus x is equal to 180 degrees. That implies 2x is equal to 180 minus 100 is nothing but 80, which implies x is equal to 40 degrees. Therefore, we got angle Q is equal to angle R is equal to 40 degrees. Moving on to question number 11. In figure, OA is equal to OB, OC is equal to OD and angle AOB is equal to angle COD. Prove that AC is equal to BD. Now moving on to solution. Given that OA is equal to OB and OC is equal to OD and also angle AOB is equal to angle COD, and he asked us to prove that AC is equal to BD. So now let us prove that. Let us consider that angle AOB is equal to angle COD. Let us subtract angle COB from the both angle COD. Let us subtract angle COB from the both then we get that angle AOB minus angle AOC is nothing but, it is given that OA is equal to OB and OC is equal to OD and also angles AOC is equal to angle BOD. We got it in above. Now by SAS congruence rule, we can say that both the triangles are congruent. That is, triangle AOC is congruent to triangle BOD. Therefore, we know that when two triangles are congruent, then their corresponding sides and angles will be equal. Therefore, here the corresponding side of AC is nothing but BD. Therefore, AC will be equal to BD. That's what the required proof for us. Moving on to question number 14. Prove that two distinct lines can't have more than one point in common. Now moving on to solution. It is given that there are two distinct lines. Let us assume them as L and M. We are required to prove that they have only one point in common. Now in the proof, let us consider two lines L and M. On L, in the proof, let us assume that L and M have two distinct points in common, that may be P and Q. So therefore, P and Q lie on M and as well as on M. Therefore, we can say that there exists only one line L is equal to M. But we assumed that L and M are two distinct lines. So, our assumption that two distinct points in common that may be P and Q. So therefore, moving on to 17th question. In figure, it is given that PQ is equal to PR, angle AOQ is equal to 2 times angle BQR, and angle BOR is equal to 2 times angle ARQ. Prove that triangle PQB is congruent to triangle PRA. Now moving on to solution. Let us note down the given information that PQ is equal to PR and AOQ is equal to 2 times angle BQR and angle BOR is equal to 2 times angle ARQ. Now we are required to prove that triangle PQB is congruent to triangle PRA. So here it is given that angle AOQ is equal to 2 times angle BQR. Also angle BOR is given as 2 times angle ARQ. Now let us move on to the proof. Now if we consider angle AOQ and angle BOR, they are vertically opposite about the common point O. We know that the vertically opposite angles are always equal. We can say that angle AOQ is equal to angle BOR since they are angle ARQ. Now let us move on to the proof. Now if we consider angle AOQ and angle BOR, they are vertically opposite about the common point O. We know that the vertically opposite angles are always equal. We can say that angle AOQ is equal to angle BOR since they are vertically opposite angles. Therefore, as angle AOQ is equal to angle BOR, we can say that 2 times angle BQR is equal to 2 times angle ARQ. That implies angle BQR is equal to angle ARQ. As it is given that PQ is equal to PR in the whole triangle, we know that in a triangle the angles opposite to equal sides are equal. We can say that angle Q is equal to angle R in this triangle, but we can write angle Q as angle AQB or angle PQB plus angle PQB plus, and this angle is BQR. That is equal to Angle R is nothing but angle ARQ plus angle PRA. But we came to know that angle BQR is equal to angle ARQ. Therefore, this will be cancelled on both sides. That implies angle PQB is equal to angle PRA. Congruent, that is triangle PQB is congruent to triangle PRA. Therefore, when this is what the required proof for us. Now moving on to 18th question. Prove that the two lines which are both parallel to same line are parallel to each other. Now moving on to solution. Given that there are two lines which are parallel to the same line, so let us assume that L and M are two lines that are parallel to common line N. That means L is parallel to N and M is parallel to N. Now we are required to prove that all the lines, we are required to prove that the two lines that are parallel to a common line are parallel to each other. That means we need to prove that L is parallel to M. In order to prove that, let us move on to the proof. Here, let us consider that L, M and N as three lines, so that L is parallel to N as well as M is also parallel to N. We need to prove that L is parallel to M. In order to prove that, let us draw a transversal P and let us say that they intersect line L at A, line M at B and line N at C. Then as L is parallel to N, we can say that the alternate interior angles will be equal. Therefore here let us name this angle as angle 1 and let us name the alternate interior angle of 1 is angle 2 on line L. Therefore angle 1 is equal to angle 2. And in the second case, if we consider, given that M is parallel to N, in the second case it is given that M is parallel to N. Therefore, if we consider that M is parallel to N, we can say that alternate interior angle represented at B by 3 is equal to 2, since when line M is parallel to N and P is transversal, angle at B that is represented by 3 will be equal to angle 2, since they are alternate interior angles. Moving on to question number 20. In the given figure, lines XY and MN intersect at O. If angle POY is equal to 90 degrees and A is to B is equal to 2 is to 3, then find the value of C. Now moving on to solution. It is given that XY and MN intersect at O. Angle POY is equal to 90 degrees and A is to B angles are given in the ratio 2 is to 3. Then find the value of C. So here let us note down the ratio of given angles, that is A is to B is equal to 2 is to 3. Let us assume that angle A is equal to 2x and angle B is equal to 3x. We know that angle A comma angle B comma angle POY form a linear pair since they lie about the same line. Therefore we can say that sum of angles lying about the common line is equal to 180 degrees. Angle A plus angle B plus angle POY here is nothing but 90 degrees is equal to 180 degrees. That implies angle A is nothing but 2x plus angle B is nothing but 3x plus 90 degrees is equal to 180 degrees. That implies 5x is equal to 180 minus 90, that is nothing but 90 degrees, which implies x is equal to 90 degrees by 5. So finally we got x is equal to 18 degrees. So B will be equal to 3 times x, that is equal to 3 times 18 degrees, which is equal to 54 degrees. But here if we observe, angle B and angle C are lying about the same line MN, and the common line passing through the point of intersection O is XY. Therefore here angle B and angle C form the linear pair about MN. We know that sum of angles that form a linear pair is equal to 180 degrees. Angle B plus angle C is equal to 180 degrees. That implies B here is nothing but 54 degrees plus C is equal to 180 degrees. That implies C is equal to 180 minus 54 degrees, which is nothing but. Now moving on to 28th question B. In the given figure, angle x is equal to 62 degrees, angle xyz is equal to 54 degrees. If YO and ZO are the bisectors of angle xyz and angle xzy respectively of triangle xyz, then find the value of OZY and YOZ. Now moving on to solution. Here it is given that in triangle xyz, angle x is equal to 62 degrees, angle xyz is equal to 54 degrees. Now we know that in triangle xyz, by angle sum property we can say that sum of angles in any triangle is equal to 180 degrees. That implies angle x plus angle y plus angle z is equal to 180 degrees. That implies angle x is nothing but 62 degrees plus angle y is nothing but 54 degrees plus angle z is equal to 180 degrees. That implies angle z is equal to 180 minus 62 plus 54 is nothing but 116 degrees. That is equal to 180 minus 116 is nothing but 64 degrees. Therefore we got angle z as 64 degrees here. He says that YO is the bisector of angle y and ZO is bisector of angle z. Therefore here we can say that angle OYZ is equal to half of 54. That is nothing but 27 degrees, and angle OZY is equal to half of 64, that is equal to 32 degrees. But in triangle YOZ, let us again apply the angle sum property. Then we get that sum of angles is equal to 180 degrees. That is nothing but angle OYZ plus angle OZY plus angle YOZ is equal to 180 degrees. That implies here we have OYZ is equal to 27 degrees plus angle OZY is equal to 32 degrees plus angle YOZ is equal to 180 degrees. That implies angle YOZ is equal to 180 degrees minus 27 degrees plus 32 degrees. that is equal to 180 degrees minus 27 plus 32 is nothing but 59 degrees. That is equal to 180 minus 59 degrees is nothing but 121 degrees. Therefore here we got YOZ value as 121. Now moving on to question number 23. In given figure, if PQ is perpendicular to PS and PQ is also parallel to SR, angle SQR is equal to 28 degrees and angle QRT is equal to 65 degrees. Then find the values of X and Y. Now moving on to solution. Here it is given that PQ is perpendicular to PS and PQ is equal to SR and angle SQR is given as 28 degrees and angle QRT is given as 65 degrees. Then find values of X and Y. Now let us initially consider that PQ is parallel to SR and QR as transversal. Then we can say that angle PQR is equal to angle QRT, since these are nothing but the alternate interior angles. That implies angle PQR is nothing but X plus 28 degrees, that is equal to angle QRT is nothing but 65 degrees, which implies X is equal to 65 degrees minus 28 degrees, that is equal to 37 degrees. Therefore we got the value of X as 37 degrees. Now in triangle PQS, by applying the angle sum property, we can say that sum of angles is equal to 180 degrees, that is X plus Y plus, here the angle QPS is given as 90 degrees, that is equal to 180 degrees, which implies we know angle X is equal to 37 degrees plus Y plus 90 degrees is equal to 180 degrees. That implies 127 degrees plus Y is equal to 180 degrees, which is nothing but Y is equal to 180 degrees minus 127 degrees, which is nothing but 53 degrees. Moving on to 26th question. In the given figure, the side QR of triangle PQR is produced to a point S if the bisectors of angle PQR and angle PRS meet at point T. Then prove that angle QTR is equal to half times angle QPR. Now moving on to solution. So here triangle PQR is given such that QR is extended to S and the bisector of PQR is intersecting the bisector of PRS at T. He asks us to prove that angle QTR, that is this angle, is equal to half times angle PQR. Now in solution, let us consider triangle PQR. We know that in any triangle, external angle is equal to sum of two opposite interior angles. Therefore here we can say that the exterior angle, which is nothing but angle PRS, is equal to the sum of two opposite interior angles, that is nothing but angle QPR plus angle PQR. Now let us also consider in triangle QTR. In this also the external angle will be equal to sum of two opposite interior angles, that is nothing but angle TRS is equal to angle TQR plus angle QTR. Now we know that QT is bisector of angle Q. Therefore we can say that angle TQR is nothing but half times angle PQR, and also we have TR is bisector of angle PRS. Therefore we can say that angle TRP or angle TRS is equal to half times angle PRS. Now let us name these equations as 1, 2, 3 and 4. Here we have angle TRS is equal to half times angle PRS. Therefore we can write the second equation as half times angle PRS is equal to angle TQR plus angle QTR. That implies angle PRS. Moving on to 27th question. Triangle ABC is an isosceles triangle in which AB is equal to AC. D, E and F are the midpoints of sides BC, AC and AB respectively. Prove that DE is equal to DF. Now moving on to solution. He has given that ABC is isosceles triangle. So let us draw an isosceles triangle A, B, C in which AB is equal to AC, and it is given that D is the midpoint of BC and E is the midpoint of AC and F is the midpoint of AB. Now he asks us to prove that DE is equal to DF. Now moving on to the proof. It is given that AB is equal to AC. We know that in a triangle, angles opposite to equal sides are equal. Therefore here the angle opposite to AB is C and angle opposite to AC is nothing but B. Therefore here angle C is equal to angle B, and it is given that F is a midpoint of AB. Therefore here BF will be equal to here, as F is the midpoint of AB, we can say that BF is equal to half FB. Here, as F is the midpoint of AB, we can say that BF will be equal to half times AB, which implies AB is equal to 2 times BF. And it is given that E is a midpoint of AC, therefore CE will be equal to half times AC. That implies AC is equal to 2 times CE. But we know that it is given AB is equal to AC. That implies 2 times BF is equal to 2 times CE, which further implies that BF is equal to CE. Now it is given that D is the midpoint of BC, therefore here BD will be equal to DC. So now let us consider in triangle BDF and triangle CDE. In these both triangles, moving on to 27th question, B bit. In an isosceles triangle, if vertex angle is twice the sum of base angles, find all the angles of the triangle. Now moving on to solution. Let us assume that ABC is an isosceles triangle. Let us assume that ABC is an isosceles triangle in which AB is equal to AC. So let us draw an isosceles triangle ABC in which AB is equal to AC. It is given that the vertex angle A is equal to twice the sum of the other angles. That is, it has been given that angle A is equal to 2 times angle B plus angle C. We know that in any triangle, the angle opposite to equal sides are equal. Therefore here, as AB is equal to AC, the angle opposite to AB is angle C. That will be equal to angle opposite to AC is angle B. Let us assume their values to be x. But here we have angle A is equal to 2 times angle B plus angle C, that is nothing but x plus x, which is equal to 2 times x plus x is 2x, which is equal to 4x. Now we know that by angle sum property in any triangle, sum of angles is equal to 180 degrees. Therefore here we can say that angle B plus angle A plus angle C is equal to 180 degrees. That implies A angle is given by 4x plus